Hey everybody, welcome to another edition of Probably Private. I'm Catherine Jarmal, and today we're going to talk about differential privacy in machine learning and deep learning. Now, hopefully you already caught the first video on this, where I'm really introducing you to the concept of differential privacy and how it works in deep learning. And there's, of course, some articles about this too. But today, what we're actually going to talk about is we're going to move into what I consider to be some more difficult parts. So you've kind of already decided you're going to use differential privacy in some sort of deep learning. And now, what are the hard parts that you're going to run into? And I'm going to make some assumptions here. So I'm going to already assume that privacy and privacy technology is prioritized and on the roadmap. So if you're not at that stage, that's the hardest part. So you can just, stop watching this video and go try to work on that part of the problem. So that's obviously one of the biggest hurdles. And then another big hurdle is that you have the competency at the organization or on the team around differential privacy and or machine learning, and also maybe the buy-in from leadership or management that you're doing this, for the first time, or you're doing it as one of the first times. And getting that buy-in is critical for being able to do the other parts of the process. Obviously, I also offer support for some of these things. So if you want to reach out, I offer trainings, I offer advisory. I'm good at talking with management. These are all things that I offer via my company, K Jamison. Okay. The first big question, once we have that buy-in, once we have some competency, is actually starting to define what data we're trying to protect and how. So I just have here, for example, as an example, how we do deep learning around language right now, usually, right? We have data collection, we have some sort of extraction, maybe selection method, we have pre-training, then we have training or fine-tuning or both. We have some sort of evaluation and validation process that we run, or maybe multiple times, right? So some of these could be multiple steps that we go back to. And then we have actual inference time. So when we're running it in some sort of production system or whatever it is we're using it for, right? And this is often also cyclical, right? So when we're doing inference, we're often also collecting more data and we're repeating this process to some degree. Maybe sometimes not going through every step, maybe skipping directly to fine-tuning and evaluation with the new data that we collect. But either way, this is what it looks like. So we're collecting a lot of data, we're processing a lot of data. And one of the big questions is, what parts of this process should we apply, or should we think about the guarantees like differential privacy? And one pattern that happens in industry is maybe only doing this fine tuning with differential privacy. So only doing this, fourth step. And what some researchers found, and I'll link the research, is that if we're using differential privacy to avoid memorizing, let's say, potentially sensitive information about persons, if we're pre-training with no differential privacy on sensitive information, even if it's web collected data, because web collected data, scraped data has sensitive information, we can still memorize, right? And there's been numerous examples of this, of people getting their cryptocurrency wallet identifier and keys taken because it got memorized, of people having medical records exposed because it got memorized. So this is not just theoretical, this is real. And therefore, when we're thinking about the entire life cycle, especially when we're talking about something like language modeling or even, image generation or something like this, we need to think about the fact that there's many places where we're potentially dealing with sensitive information. And when we think about the guarantees that differential privacy is trying to offer us, that no one individual should be able to be identified based on their contribution, or at least we should be able to limit the ability that they're identified based on their contribution. We have to think through actually this entire process. And so I'll link the longer article I have written on this, where I both cite a bunch of research, but I also give some tips. But when you get started on this, really take a look at this and try to define where is the sensitive data. And when we're shaping the problem for differential privacy, have we really shaped it to match where we think the sensitive data lies? And if we're dealing with memorization, where we think the memorization problem lies. Okay. Moving on, when we're doing differential privacy and when we're also fighting, let's say, memorization as a quality of, let's say, larger deep learning networks, what we need to ask ourselves is perhaps step back a little bit. Why is there memorization risk within this task and this problem? And is it because we don't have diverse and representative data? Because just adding differential privacy without actually thinking through, why am I concerned about memorization in this problem? And does my data pose a significant memorization risk? This, asking this yourself and then trying to answer this larger question of, do you have diverse and representative data, will help get to the point of when and where can differential privacy help. Because here is an image which we first talked about, is a graph that's cited in Feldman's research on memorization in deep learning. And it goes to show that, majority classes, we can learn well with privacy because it's a majority class and we have lots of representative data. And then even within that majority class, there's less represented data. I don't necessarily want to call all of them outliers because it might just be underrepresented in the type of data that we have. But either way, it's underrepresented data. And what we know about how differential privacy works is it will do its best to try to protect that underrepresented data. So if we have a lot of data that is very representative and we have numerous diverse examples of that representation, we can learn the task well with privacy. If we don't have those things, we might not even be able to learn the task without privacy, or at least not very well for everybody, right? So what I want you to get curious about and start thinking about is, what is the task that we're trying to learn for overall? What would it mean to have diverse and representative data? And then apply that with what is known about differential privacy and learning theory. And again, I'll have some links and I have a video that I recommend that you take a look at as you start to reason about what amount of data you might need to learn the same task without memorization and with privacy. So again, difficult examples, or at least in this paper, this Carlini paper, outliers, called outliers, right? And easy examples. So easy examples, again, because they're both less complex and because we'll have many repeats of the same thing. We can learn that with differential privacy. More difficult examples we might not learn. And depending on your problem, it might be okay to not learn the more complex examples. That might be okay, right? To get some of these types of examples wrong. So you just have to decide for your task, how do you get more diverse and representative data? And at what level of error for these less represented data or more complex examples, at what point is an acceptable amount of error for the fact of then not running into the memorization problem? Then the third question I have for us to think about today is to start questioning, is the task that we're doing actually privacy preserving? So this is from a really thought-provoking paper that if you work with language data, I highly recommend that you check out. But it's by Brown et al. And they looked at basically, can a language model, the way we build them today, can a language model ever be privacy preserving? And they take the paradigm of contextual integrity, which basically means when I share information, in this case, when I share text, I share it with open knowledge and consent for the types of environment or context that it might be used in. So here we have some examples. We have, let's say, a password file, which I should never share, or a secret key, which I should never share, right? We have maybe something like my IDs or my credit cards. I'm sending it to one person under some sort of trust, under some sort of context, and I expect them to use it within that context, right? Then we have another one. I'm posting my email address because I'm running a business and I want people to be able to email me. But I mean that to be used in the context of my work. I don't really necessarily want an LLM to randomly repeat my email address outside of the context of my work, right? So this is maybe something that's a little bit context bound. And then let's say a credit card that we're all able to use, let's say, or an internal email address we're all able to use, right? That's within a group, but it's not really supposed to be shared outside of a group, okay? So here's just some examples. You can already see here, this is complex. This is like hard. This is hard to define even with these examples, but we're about to get more complicated. What about your search history? You probably think is pretty private. If not, I can give you some links as to why you might think it's private or should think it's private, right? It's up to you what you consider private, but your search history probably has a lot of information about you. Okay, let's look at the next example. Somebody is talking with a counselor or a therapist. This is two people, high trust environment, but this could be recorded, digitized, other things like this. The third one, an email gets released. This is, an example from the famous Enron emails, which is an open data set that has things like social security numbers, credit card numbers, other things like this. That was released because the Enron emails were released as part of the investigation into fraudulent behavior at the company, but it wasn't done a very good job of privacy release of that data. And there's many examples of text data sets that follow, not necessarily exactly the type of Enron paradigm, but still follow the paradigm of nobody really bothered to make sure that sensitive data was removed from this before they released it online. Then we have another example, which is quite common, that somebody sends me some information and then I send it on to somebody else. This is sharing outside of context. To some degree, this is a breach of trust, right? And then finally, we have, example of a huge whistleblower public release, which again, I'm not anti-whistleblower, but usually this is not done in a way where redaction or even really thinking through what pieces of this release are important to release and what ones, for privacy reasons, should we maybe not release. This often isn't thought through. And so when these are the types of language data sets we're dealing with, what we have to ask ourselves is, no matter whether we do differential privacy or not, is learning with this data ever going to be what we call privacy preserving? Like, is it ever going to be respectful to somebody's privacy to take their text out of context and train on it? So it's a bit of a philosophical question and probably something that each person or each team might decide differently. But it's something also in a work context for you to actually think about, hey, maybe this data is totally out of context, and no matter how much differential privacy we use, we're kind of abusing that trust. Whereas this data is maybe very specific to the type of task we're learning, and we're communicating with the users that we're going to use this data for machine learning. And therefore, we feel really good that the consent is well defined, that the context is well defined, and that we understand also by adding something like differential privacy that we're kind of putting our best effort into doing text or LLMs in a privacy preserving way. And I'll have more links on this discussion again in a longer article. I'm curious as to your thoughts on this and the conversations that you've had around this. And then finally, one thing where I see a lot of differential privacy projects fail is getting the right people in the room to collaborate the right way. And here I just give an example of a fun, like multiplayer, multidisciplinary game that I helped develop when I was still at ThoughtWorks all around AI governance. with Jim Gumbley and Aaron Nicholson. And we're three different experts. I'm the nerd. Aaron's the privacy policy, organizational privacy expert, and Jim was the cybersecurity expert. And it was really fun to just collaboratively think through problems of AI governance and other things like this, and bring these different disciplines and contexts to learn from each other, to collaborate, to start to define standards. So what is the standard that we're going to use at the organization for something like differential privacy in deep learning? How do we design use cases collaboratively so that we know that it meets legal requirements, that it also is well understood? So part of it is learning to speak each other's language. If you're just getting started in privacy, you're going to have a really fun path ahead of you of learning how to interact with people coming from the legal side, coming from the product side, if you, like me, are coming from the technology side. And if you're coming from the other way, then you're going to learn a bunch of nerdy technology words. And as you're able to expand your vocabulary and create shared vocabulary, these conversations are going to be easier and easier and also more fruitful, right? Because you're going to be able to make decisions faster, understand each other more quickly. And by doing this, you're going to also empower teams. So in the beginning, when you're setting up these multidisciplinary processes, it's going to seem hard and difficult. And why doesn't this person understand what I'm saying? And all of these things, right? But as you build that muscle and also start to build out the tools and processes for that muscle, you're going to be able to make decisions quickly, and maybe even at some point in time, share processes that are instructive enough that teams can get started right away. So as you first start with differential privacy, there's probably going to be a struggle to make sure everybody understands what guarantees can it offer, how does that fit into compliance or product, and what we want to do in machine learning. And then over time, you're going to be like, oh yeah, we've done that before. Like, here's kind of what we thought about. Here's the process we went through. Here's the tooling we used. And as that gets more and more ready, you might eventually even be able to build it into a machine learning platform that you use, build it into the normal testing and training environments you use. And as you gain this competency, it's going to be a lot faster. But if you don't bother to do this in the beginning, I can't guarantee anything, but I can promise you it's going to be harder later to go back and get all the people in the room to discuss how does this fit into our overall strategy from a security perspective, from a privacy perspective, and also from a product and, management, quote unquote, business perspective, right? And if you can get that aligned early on and collaboratively design that, you're going to reap the benefits later. This much I promise you. I'll post the references down under, but I'm also curious, have you been using differential privacy at work? How have you been using it? Or are you just getting started? I'd be very curious to hear your experiences and tips that you have for each other. And of course, please feel free to reach out if you want to engage with me and my company in ways to see ways that maybe I could be of use if this is the path that you're going down. Now, stay tuned. In the next video on differential privacy, we're going to be talking about parameter choice and accounting and auditing. So stay tuned, and I'll see you next time.